In the previous videos, we discussed theorems as well as I discussed what is meant by invertible matrices. Clear? So now and how to find the A inverse, that also I discussed. So my dear students, please remember, if I have the any one matrix A, then if there exists another one matrix B of the same order, then if AB is equals to or BA is equals to I, in such cases we can call it as A is invertible to B. And here it is, in this case A and B are invertible to each other, or else here it is, we can call here it is A inverse is equals to B. So if AB is equals to I, if you are getting the product of AB, or if you take the BA, if this product you are getting it as the identity matrix, then we can call A inverse as B, or else B inverse is equals to A I can call. So my dear students, if I have the one matrix A, then if I multiply with the another one matrix with the same order, so if I am getting the product as identity matrix, then we can call here it is A is invertible, or here it is, in this case B is, we can call it as the invertible, and A inverse is A inverse we can call it as this value is equals to B, or B inverse we can call it as A. So in these cases A and B are invertible to each other. So this concept I discussed in the previous videos. Clear? And my dear students, now I am going to discuss the theorem. So this theorem you can also known as reversal law. So please remember, usually or generally the theorem, the proof for this theorem they won't ask. Clear? But still we should know the meaning, or we should know the proofs of how to solve. We should know. If we know the proof very well, then we can easily remember the statement. So what is important to us? The important is just the statement we should remember. But to remember the statement, we should know the proof. So that purpose I am going to discuss the proof here. Clear? So my dear students, for that what I do here is, first I will read the statement. So what is that? If A and B are invertible matrices of the same order, then show that AB is invertible and AB whole inverse is equals to B inverse into A inverse. So this we should prove. So in the last class, another one thing I told to you, that what is that? So here it is, A is invertible if and only if. So A is invertible if and only if A is non-singular. So the proof for this also I discussed in the previous videos. You can refer my previous videos to prove this result. So what it says, so A is invertible. So if A is invertible, if and only if A is non-singular. So it means what it indicates, my students? So determinant of A is not equals to 0. A square matrix A is said to be non-singular if determinant of A is not equals to 0. So therefore any square matrix A is said to be non-singular if determinant of A is not equals to 0. And also we know that, so A is invertible means what it indicates? A is invertible means determinant of A is not equals to 0. So we should always keep in our mind. So whenever I used to tell A is invertible, so A is invertible means in your mind you should think that A is non-singular. So A is non-singular means what it indicates? Determinant of A is not equals to 0. So please remember, whenever I used the statement A is invertible means you should understood that determinant of A is not equals to 0. This is so because A is invertible if and only if A is non-singular. If A is non-singular, then only A is invertible. It means A inverse exists. So therefore A is invertible means another one meaning is nothing but determinant of A is not equals to 0. So this you should continue. So now my dear students, so what is the theorem here? This I should prove. If A and B are invertible matrices, they only given that. So what is that? Given here, given A and B are invertible matrices. So just only I told you that. So invertible means what should we think in our mind? Invertible means this implies that invertible means we should conclude that determinant of A is not equals to 0 and determinant of B is not equals to 0 because A and B are invertible. Clear? And now my dear students, what I'll do? So I'll consider determinant of A into determinant of B. So if I consider determinant of A to determinant of B means this value is also not equals to 0 because here it is what I told you, what they given to you, A and B are invertible matrices. So A and B are invertible matrices means determinant of A is not equals to 0, determinant of B is not equals to 0. If I take the product of this determinant of A into determinant of B, then this product is also not equals to 0 because if any, here it is, if you take the two numbers, if you are taking the product of this means in these numbers, if any one is not equals to 0 means then their product never be equals to 0. So therefore you can have the example here. What is the example here? It is, so 1 into 0 is equals to 0, but 1 into 2 is never be equals to 2, it never be equals to 0 because to any, if I have the any two numbers, to this product is equals to 0 only if either A or B equals to 0, then only the product is equals to 0. But here it is, if A is also non-zero, if B value is also not 0 means then their product is always not equals to 0. So this concept I am using here. It is clear. So therefore my dear students, what I am writing here is determinant of here is determinant of A is not equals to 0, determinant of B is not equals to 0. This implies that if I take their products, then they are, that is also not equals to 0. So now I will write here this determinant of A into determinant of B. So can I write it as determinant of AB? Because this also I discussed in the previous video. So what is that? Determinant of AB can be written as determinant of A into determinant of A B. So here it is determinant of A into determinant of B. So determinant of A into determinant of B can be written as determinant of AB. So here it is, this value is not equal to 0 means here it is, this is also not equals to 0. So if determinant of AB is not equals to 0 means can I conclude here it is AB is non-singular. So here it is AB is non-singular because I told you that A is invertible means if and only if A is non-singular. So A is non-singular here it is, and this implies that determinant of A is not equals to 0. If determinant of A is not equals to 0 means what I can conclude here is, I can say that here it is A is invertible. So A is invertible if determinant of A is not equals to 0. Like that, determinant of AB is not equals to 0 means I can write here it is AB is non-singular. So if AB is non-singular means we can conclude here it is AB is invertible. So what I told here is A is invertible means what should we understand? Determinant of A is not equals to 0. So like that, if determinant of AB is not equals to 0 means I can conclude here it is AB is invertible. So what they given to you the theorem here it is, if A and B are invertible matrices of the same order, then show that AB is invertible. So AB is invertible, I proved here it is. Clear? So in examination no need to write this one. So directly you can write here this, if determinant of AB is not equal to 0 means we can conclude here this AB is invertible. Clear? And now my students I am going to prove this one result. So this result, what is that? AB whole inverse is equal to B inverse into A inverse. So this part I completed here this. Clear? And next I prove this result. So what is that? AB whole inverse is equal to B inverse into A inverse. So remember, AB whole inverse can be written as B inverse into A inverse. So that's why we are taking the reverse of this, B into B inverse into A inverse. So therefore we can name it as reversal law. To prove this, what I will do, my students? So let us consider AB is invertible. So AB is invertible means here it is, already I told you that A is invertible means what can I write condition here? It is A is invertible means AB is equals to or B is equals to I. It means A is said to be invertible if there exists another one matrix B such that AB is equals to or BA is equals to identity matrix, then we can say that A is invertible. So A is said to be invertible if there exists another matrix B such that A into B or B into A is equals to I, and here this B we can call it as, here it is, this B we can call it as inverse of A, or A is called as inverse of B we can call. So since AB is invertible, so what can I write, my dear students? Now AB is invertible means I can write here it is AB into this inverse, B inverse into A inverse. So this is equals to identity matrix I can write. Am I correct? Yes, I hope you understood. So now my students, now I will consider it is AB into B inverse into A inverse. I will consider it is. So AB into B inverse A inverse, this value is equals to identity matrix. So I can write. But I will consider it is AB into B inverse into A inverse. So this can be written as A into, I will take these two additions. B, I will merge this B into B inverse into A inverse. So I am considering here is, just remember, so if you are getting confused means just don't think here in this case, just forget this, just only consider here it is AB into B inverse into A inverse. Now I am taking these two here, I am merging these two. So A into B inverse into A inverse. So A into, so B into B inverse. So since B is invertible here it is, so B is invertible means B into B inverse is equals to identity matrix. Clear? So to the any matrix, if you are multiplying here it is, invertible means what? To the any matrix, if you are multiplying with the inverse of that means you should get the identity matrix. So therefore A into B inverse can be written as I into A inverse. And now my dear students, AI can be written as, so to the any matrix, if you are multiplying with the identity matrix means again you will get the matrix which is multiplying with the identity matrix. It means A itself. Clear? So A into I is equals to A into A inverse, remaining here this A inverse as it is. And now A into A inverse can be written as, here it is I. Clear? So therefore AB is equals to, sorry, AB into B inverse into A inverse is equals to I can write. So if I write this means what can I conclude, my dear students? So please remember, AB here it is, A is here it is, AB into AB is equals to I. If I write means what it indicates, AB is equals to I means here it is A inverse is equals to B and B inverse is equals to A. I can write. It means here it is, this is the one matrix, consider this as the one matrix, this as the one matrix. So if these two matrices multiplication, if I am getting identity matrix means I can write here it is, this inverse is equals to this. So AB whole inverse is equals to B inverse into A inverse. This is because this is the one matrix, this is the one matrix. So if I take the product of this means I am getting identity matrix. So if you are getting identity matrix, then you can this implies that this whole inverse is nothing but this value. Here this you can observe here this. If AB is equals to B is equals to I means I can write here this A whole inverse is equals to B. Likewise, this whole inverse is equals to this value. So AB whole inverse, this whole inverse I am taking. AB whole inverse is equals to B inverse into A inverse. Clear? So like this, you should prove this result. So if it is understood means very good. Otherwise, don't worry about this proof, because in your annual examinations, so in second PUC, that too for second PUC Karnataka State Board, it's not included in your syllabus. So generally they won't ask the proof for this, but we will verify this result. But as concerned for the competitive examinations, so these all are very important results. So therefore that's why I proved the result. Clear? So in board examinations usually they don't ask the proof for this. Clear? So just remember this result. And now I will prove the questions. I will verify the questions based on this result. I hope you understood. Still, if you have any doubts, you can comment me. I will reply for that. And next I will prove the results. I will prove the questions by using this result that I am going to write now. Next question I wrote, my dear students. So what is that? They given to you the A and B are the two matrices they given to you, and then verify that AB whole inverse is equals to B inverse into A inverse. So this result we should verify. And now my dear students, to prove this what I will do my dear students, first consider the here it is. Consider here we should prove this one. So now first what I will do, I will consider here it is LHS part. So our LHS part. So what is LHS part? LHS part is AB whole inverse. Clear? It means we should calculate the AB whole inverse. Clear? To calculate AB whole inverse, what should be required my dear students? To calculate AB whole inverse, we know that. So we know that one formula. What is that? A inverse. How to calculate the A inverse? A inverse is nothing but determinant of A into adjoint of A. So by using this formula, I can calculate the A inverse. But my dear students, what they ask? What you are finding? AB whole inverse. So if I wanted to find the only inverse of A means how I should write? A whole inverse is equals to 1 divided by determinant of A into adjoint of A. But now I required AB whole inverse. So for that reason, AB whole inverse is equals to 1 divided by if I required A inverse means determinant of A, but here this AB whole inverse is required. So therefore determinant of AB into adjoint of AB. Clear? So adjoint of AB I require. So to find out the adjoint of AB, first of all I should know the AB value. So for that reason, what I will do my dear students, first I will consider the AB. Because I should calculate the determinant of AB as well as adjoint of AB is required. So therefore first I will consider AB. So consider here it is AB. So how to calculate AB here? It is A is already they given to you. What is that? 2, 3, 1 minus 4. And next my dear students, B is 1 minus 2 minus 1 3. So this is A and this is B. So AB means we should multiply these two matrices. So multiplication already I told to you. How to multiply these two matrices? AB is equals to here it is. So what is the formula we have, or how to calculate the here it is product of the two matrices? Row by column. So first row, first column. So what is that? Here it is 2 into 1. First row, first column. 2 into 1. So here it is. Next plus of here it is 3 into minus 1. First row, first column. 2 into 1 plus 3 into minus 1. And next my dear students, first row, second column. So what is that? Here it is to leave some space because we are moving to the second column. So first row, first column. To the first row, first column. 2 into 1 plus 3 into minus 1. So first row, second column. 2 into minus 2 plus of this element into this element. 3 into 3. Clear? And now here it is second row. Next is second row, first column. So therefore here it is 1 into 1 plus of minus 4. You can have, I'll write in the bracket. So this element into this element. So what is that? So second row, first column. 1 into 1 plus this element into this element. Minus 4 into minus 1. Likewise, here it is. Likewise, second row, second column. So 1 into minus 2 plus this element into this element. Minus 4 into 3. So close the bracket. So row by column. First row, first column. First row, second column. Second row, first column. Second row, second column. And this is equals to, here it is, AB is equals to 2 into 1 is 2 plus minus minus 3 plus minus minus 2 2s are 4. Next plus 3 3s are 9. And 1 into 1 is 1. Minus plus minus plus 4 ones are 4. And plus into minus 2 ones are 2. Here it is plus minus. Here it is minus, in here it is plus plus minus 4 3s are 12. Clear? So therefore here it is. If you further simplify means you will get, here it is. How much it is? 2 minus 3 is minus 1. Minus 4 plus 9 minus 4 is plus 5. 4 plus 1 is 5. So minus 14. So this is what your AB. Clear? Am I clear? So therefore the matrix AB value is minus 1, 5, 5, minus 14. Clear? So I'll write here this. What is the what we should prove here this? We should prove that, my dear students. We should prove that, or else we should calculate the AB whole inverse. So AB whole inverse is equals to 1 divided by determinant of AB into adjoint of AB. This we should prove. Clear? So for this, what is required? Determinant of AB as well as determinant of adjoint of AB is required. Already I calculated here this AB. Now I will calculate the determinant of AB. So how to calculate the determinant of AB, my dear students? So determinant of AB is equals to. So determinant of AB. How to calculate determinant of AB? Here it is. The determinant of AB is equals to determinant of minus 1, 5. So here it is. I am taking determinant. This is matrix. I am taking determinant. So minus 14. So this is equals to this element into this element. Minus minus plus 14 into 1 is 14. Minus of this element into this element. 5 5 is a 25. So 25 minus 4 to 14 means here it is. Here 6 plus 5. It means 11. I think because 14 plus 11 is nothing but here it is. So 5 it's minus 11. My dear friends, please remember determinant of AB is minus 11. Minus 11 means which is not equals to 0. Please remember, so inverse is exist. Inverse exists only if determinant of AB here determinant value should not be equals to 0. So inverse exists only for the non-singular matrices. So I am finding the AB whole inverse. So AB whole inverse exists only if AB is non-singular. AB is non-singular means what it indicates? Determinant of AB should not be equals to 0. Determinant of AB after calculation I am getting it as minus 11. So therefore minus 11 is not equals to 0. So therefore here it is determinant of AB is non-singular, then inverse exists. So determinant of AB value is minus 11. And now what is required? Another one thing here is to calculate the AB inverse. I require the determinant of AB. Determinant of AB I calculated here. Next, adjoint of AB. So this is your matrix A. So how to calculate adjoint of AB here it is? So adjoint of AB is equals to. My dear friends, I told you that while discussing the concept of the adjoint. What is that? If the given matrix is of the order 2 cross 2, so in that case, adjoint of AB is nothing but what should you do? So interchange the sign here. Change the here it is. Change the diagonal elements. Am I clear? So here it is minus 14, minus 11, and change the sign of the non-diagonal. So here it is minus 5 and here it is minus 5. So this is what your adjoint of AB. Clear? So I hope you understood. Still if you have any doubts you can calculate. Please update my last classes. Clear? So here it is 14, 1 and here it is. This is what your adjoint of AB here is. Clear? So further calculate this. So further if you calculate means here it is. Put all these values in this formula. So AB whole inverse is equals to 1 divided by, what is determinant of AB? Determinant of AB is minus 11. And next my questions, what is adjoint of AB? Adjoint of AB is minus 14 minus 5 and minus 5 minus 1. Clear? So now my friends, take here it is this or else take this minus here it is. Here it is minus, here it is minus, here it is minus, here it is minus. So take minus sign outside. It means from every element of this you can take minus outside. So if you take minus outside means minus 1 whole divided by minus 11 here it is. So what is that? 14, 5, 1. I am taking minus from each element. I am taking minus outside. So that minus that minus and another below minus we have. So this minus and this minus will become plus. So therefore 1 divided by 11, 14, 5, 5, 1. So this is your AB whole inverse. You can call it as 1. Or else you can, this is your LHS value. You can call this as LHS, or you can write it as 1. So this is what your AB whole inverse. And now my students, we should check AB whole inverse whether it is equals to B inverse into A inverse or not. To calculate B inverse and A inverse, again we should calculate B, again we should consider the matrix B and matrix A, and then we should calculate B inverse and A inverse. So what should we verify that is this value, whether I am getting after calculation of B inverse and A inverse, the same value I will get or not, that I should check. To calculate that, we should calculate the B inverse and A inverse. So now let, or else next again consider here this. Now A is equals to, so A inverse and B inverse both are required. First I will consider the matrix A. So I should calculate the A inverse. Now A inverse is equals to, what is the formula? A inverse is equals to 1 divided by determinant of A into adjoint of A. And now what is the then my distance? What is determinant of A? So here it is. Before that, here it is. Before that I consider the adjoint of A. So what is adjoint of A? Here it is. So adjoint of A is, what is the, first I write what is the matrix A. So then easily you can calculate. So A is equals to 2, 3, 1 minus 4. Clear? So even though I wrote here this, just for your understanding purpose I wrote. So directly what I write. So first I consider the, here it is. Now A is equals to, here it is. A is equals to, this is the matrix. So what is required to us? Which is, we should require the determinant of A. So how to calculate determinant of A? Determinant of A is equals to this element into this element. So minus 4 into 2 is minus 8. Minus of this element into this element. So 3 ones are 3. So minus 8 minus 3 is, here it is minus 11, and which is not equals to 0. So then it means A inverse exists. So here this determinant of A is not equal to 0. And now my distance, to calculate A inverse, what should I require? Determinant of A I require, as well as adjoint of A I require. So I will calculate, here it is adjoint of A. So how to calculate what is the adjoint of A? So adjoint of A is, so to the, if this is the matrix A I have, to calculate adjoint of A, what should I do? So I should interchange the diagonal elements. So first here I wrote minus 4 and here I wrote 2. So interchange the diagonal elements and change the sign of the non-diagonal elements. Clear? So this element and this element's sign we should change. Here it is 4 plus 3 is there, it's minus 3, plus 1 is there, it's minus 1. So this is adjoint of A. So I have the determinant of A value, I have calculated the adjoint of A. So therefore A inverse is equals to 1 divided by determinant of A into adjoint of A. So this will gives you, so what is that? Determinant of A is 1 divided by minus 11 into adjoint of A. Adjoint of A is minus 4, minus 3, minus 1, 2. So then my distance, again here it is, here you can calculate, here it is further, you can calculate, but as of now I write only this much. And now I will calculate the B inverse, because we should know the A inverse, we should multiply B inverse and A inverse. So this is all about the A inverse value, and even I required the B inverse value, I required B inverse value. So therefore consider, now again consider, next consider B is equals to. So what is B is equals to? B is here already given to you. What is B here? 1 minus 2 minus 1 3. Clear? So now what is adjoint of B? Here it is adjoint of B is equals to, just interchange the diagonal elements. Here it is 3 3 and here it is 3 1, and change the sign. Minus 2 is there, plus 2, minus 1 is there, plus 1. This is your adjoint of B. Is it visible to you? Just I'll check. Yes, it's visible to you. And now my students, B value is this much, adjoint of B, and next I will calculate, here it is determinant of B. So how to calculate determinant of B? This element into this element. So 3 ones are 3, minus of this element into this element. So minus minus plus plus into 1 into 2 is plus 2. So here it is plus 2. So 3 minus 2 is equals to 1. And here this is also not equals to 0. It means B inverse also exists. Because determinant of B is not equals to 0. Determinant of B is not equals to 0 means what it indicates? B is non-singular. So therefore, here it is. Next we will calculate B inverse. So I will erase this one. So what is that? I consider the B inverse. So B inverse, what is the again formula? What is the formula we have? So here it is. B inverse is equals to 1 divided by determinant of B into adjoint of B. This is equals to 1 divided by, what is determinant of B? Determinant of B is equals to 1 divided by 1 it is. And what is adjoint of B? Adjoint of B is here it is 3 to 1 1. So here it is 3, here it is 3 to 1 1. And 1 by 1 is 1 itself, so leave that. Directly I will get here this 3 to 1 1 is your B inverse value. Now what should I check, my students? B inverse into A inverse. Clear? So therefore B inverse or value I know, as well as A inverse value I calculated. Am I clear? So therefore here it is. Consider this B inverse into A inverse. Now here it is, or else consider B inverse into A inverse. So what is B inverse value? B inverse value I calculate here is 3 to 1 1 into, and next here this is B inverse. And what is A inverse? A inverse already I calculate here this. A inverse is equals to 1 divided by minus 11 into minus 4 minus 3 minus 1 2. Clear? And now my students, here it is. What is AB whole inverse? I got here it is. AB whole inverse is equals to 1 divided by 11, 14 5 5 1 I should get. So then this is equals to, here it is 1 divided by minus 11 I will take outside. So 1 divided by minus 11 I will take outside, and I will take this 3 2 1 1. I will multiply these two matrices into minus 4 minus 3 minus 1, and it is minus 4 minus 3 minus 1 2. And now this is equals to 1 divided by minus 11 as it is. Now multiply these two. Again here it is row by column. So what is the formula we have? If I wanted to multiply two matrices means row by first row first column. So if you multiply means here it is 3 into 4. So minus 12, and 2 into minus 1 is minus 2. First row first column. First row second column. So what is that? 3 minus 9. 3 3 is a 9. Plus of 2 2 is a 4. Clear? And next second row first column. So 1 into minus 4 is minus 4. 1 into minus 1 is minus 1. And next second row second column. So 1 into minus 3 is minus 3. 1 plus 1 into 2 is 2. So this is equals to, my difference, my 1 divided by, here it is 1 divided by minus 11 as it is. So minus 12 minus 4 minus 2 is minus 14. Clear? Minus 9 plus 4 is plus 5. Sorry, it's minus 5. Minus 9 plus 4. And next minus 4 minus 1 is minus 5. Minus 3 plus 2 is minus 1. So this is what your, my difference, B inverse into A inverse value. Further I will simplify this. If you simplify means here it is. Here also minus 14 is there, minus 5 is there, minus 5 is there, minus 1 is there. So I am taking minus from all the elements of this matrix. I am taking minus outside. So if I take minus outside means what happens? So the another one here it is minus 1 into, here it is minus 1 into 14 5 5 1 whole divided by minus 11 is as it is. From this I am taking minus. So this minus and this minus will get cancelled. I mean it will become plus. So therefore 1 divided by 11 into 14 5 5 1. So this is what your B inverse into A inverse value. Clear? So here it is B inverse into A inverse is equal to this much. I will name it as, I will call it as 2. So now my distance from 1 and 2. So from 1 and 2. from 1 and 2. So here this AB whole inverse value is 1 divided by 11, 14, 5, 5, 1. And similarly, B inverse into A inverse value is 1 divided by 11, 14, 5, 5, 1. So both the values are same. So from 1 and 2 I can, since both the value, this value and this value is same, it means that this value and this value is also equal. So therefore from 1 and 2, what I conclude here is AB whole inverse is equals to B inverse into A inverse. So this is what they asked you to prove. So that I proved here. So still if you have any confusions or any doubts, if you have means you can comment me, I will reply for that. So simple it is but lengthy. Clear? So please try to work out such type of questions. Sometimes they may ask such type of questions also. Clear? I hope you understood. Still if you have any doubts, please try to comment me. Clear? We'll continue remaining questions. We'll continue in the next class. Thank you. Please pause the video to note it down. Thank you.